In this video, we will solve a problem on how to find the returns to scale of a given production function. The question is, what kind of returns to scale does the given production function exhibit? We have a production function that means f of xy, that means production is a function of two inputs x and y, that is equal to 8xy square minus x cube minus y cube plus 0.5 x raised power 1.5 times y raised power 1.5 divided by x square minus xy plus twice y square. Okay, so we need to find out whether this production function exhibits increasing returns to scale or decreasing returns to scale or constant returns to scale. Okay, for that we need to find out the homogeneity of this very production function. Okay, so by homogeneity, what we mean, a production function is said to be homogeneous of degree n. Okay, so a production function is said to be homogeneous of degree n if when each input is multiplied by some number, let us say t. Okay, output increases by a factor tn. Okay, let me repeat it here. A production function is said to be homogeneous of degree n. Okay, if when each input is multiplied by t, okay, output increases by t raised power n. Let me explain it here. Let us say we have a production function f of xy. Okay, now if this production function f of xy is multiplied by a factor, let us say by factor t. This is also multiplied by factor t. That means if each input is multiplied by factor t, and if the output increases by the factor t raised power n, okay, f of xy, okay, if each input is increased by a factor t, and if output increases by a factor t raised power n, we say the given production function is homogeneous. Okay, and it all depends upon this n. If n is greater than 1, we have increasing returns to scale. If n is less than 1, we have decreasing returns to scale. And if the value of n is equal to 1, we will have constant returns to scale. Okay, simple thing. Given a production function, if each input is multiplied by a factor t, and if the output increases by a factor t raised power n, we say the given production function is homogeneous. And the degree of homogeneity depends upon the value of this exponent n. If n is greater than 1, we have increasing returns to scale. Otherwise, we have decreasing returns to scale. If n is equal to 1, we have constant return to scale. So, okay, so having this in mind, given this production function, let us say we increase each input by a factor t. Okay, so let us say each factor, we have f of x is increased by a factor t, so we have t raised power x, and y is also increased by t, so t raised power y. When each input is increased by a factor t, so we will have here 8, since x is increased by a factor t, so here we will have also t raised power x. Okay, so here we will have t raised power y square. Okay, so this is the first term only, we are multiplying each input by t. Then we have minus, in place of x we have x raised power 3. Then we have minus, in place of y we have t raised power y cube, and let me rub this out. Then we have 0.5. In place of x we have t raised power x raised power 1.5. Then we have, in place of y again we have t raised power y. So each input is multiplied by a factor t, so we have 1.5 as exponent here, whole divided by this x square. So in place of x square we have t x square. In place of xy, so x is multiplied by t, so we have tx Y is also multiplied by factor t, so we have ty plus twice, in place of y square we will have ty square. Okay, let us solve with this now. So let us rub this out now. So what will we have here? So we have here 8 t. Okay, so we have 8 t raised power so okay, 8 into t into x and t square y. Okay, I'm expanding this now. So we have t cube x cube minus t cube y cube plus 0.5. We have t raised power 1.5 here and x raised power 1.5. Here it is okay, it's multiplied here. So we have t raised power 1.5 again and y raised power 1.5. Okay, I'm just expanding this. Divide by this, let's expand here also. So we have t square x square minus, so here we have t into t is t square x y plus twice, here again expanding t square y square, which becomes, and let's write it here. So t into t square is t cube, so we will have, let me write it here. So we have 8 into t cube, okay, and we have x, here we have y square, I forgot to write it here, y square. Okay, so let me write it here, y square. Then we have minus here, minus t cube x cube minus t cube y cube plus 0.5. So t raised power 1.5 times t raised power 1.5, again it is t cube. Okay, base are same, we can add the exponents. Then we have x raised power 1.5, y raised power 1.5. Divide by we have t square x square minus t square xy plus twice t square y square. Okay, now let us factor t cube out of this. So we will have t cube and we are left here with 8 x y square minus x cube minus y cube. Then we have plus 0.5 x raised power 1.5 y raised power 1.5. We have factored out t cube in all these terms. Divide by, let's factor this t square. So factoring t square out, we are left with x. Okay, we have x square minus xy plus twice y square. Okay, here this t square and t cube, one t gets cancelled, so we are left with, and let me write it here, we are left with, where do I write now? So this becomes t raised power 1. Okay, and let me write it here, 8 xy square minus x cube minus y cube plus 0.5 x raised power 1.5 y raised power 1.5 divided by x square minus xy plus twice y square. Here you can see when each factor was, it is actually f of tx ty. When each input was increased by a factor t, output increased by a factor t raised power 1. Okay, as I have told you earlier, in a homogeneous production function, let us say if we have f of xy is a given production function, if each input, let us say f of tx ty, if each input is increased by a factor t and if output increased by t raised power n, okay, we say the given production function is homogeneous, and the homogeneity is found by the value of the exponent. If n is equal to 1, we will have constant returns to scale. If n is equal to, rather n is less than 1, we have decreasing returns to scale. If n is greater than 1, we will have increasing returns to scale. Here in place of n, we have 1, since the exponent is 1 here, so we can say that the given production function here in place of n is equal to 1. Okay, we say the given production function exhibits constant returns to scale. Okay, so the given production function exhibits constant returns to scale. I hope I make myself clear in this video. Thank you.